Good afternoon.
Good afternoon.
So, how is everyone today? All right, first day of MPC. All right, well, let's see who's there. All right, so Chloe sent me an email. She'll be out today, but it's going to be here tomorrow. But we've got Skylar there, holding down the fort at Winslow High School. So good to see you, Skylar. All right, then in St. John's, they're just coming in there, it looks like. All right, so let's jump to Mogollon. We have Joran and Hannah. Okay, no Hannah Whipple this time, just Hannah. You don't.
There is Hannah Whipple, no Hannah Zen.
That's what I meant.
I got you.
No, I mean,
you don't have to specify.
You get just your first name. Now you're like Madonna or whatever.
Yeah, I think that's the first time that's ever happened.
Yeah. Well, that's all right. That's okay. So anyway, glad you're here, Hannah and Joran. And let's see. So St. John's, we've got David, and how about Aiden and Joey?
I'm here. Joey's still coming in.
Oh, okay.
He came in, but then he went somewhere. I don't know where.
Oh, okay. Oh, that's his backpack right there?
Yeah, right there.
Okay. So, all right. Well, so at least we've got everybody. So let me know at the end if something happens and he doesn't show up, if a counselor or something waylays him. Okay. So, I just want to do a little bit of intro here before we get started. I'm not really going to go over the syllabus in big detail, but we'll kind of gloss over it a little bit. Let's see. Hold on just 1 second. Okay, so first of all, I kind of wish, just for this part, I wish that even the people that decided not to take Calc 2 were here just for this part, because I want to tell you guys that in all my years of teaching, I've actually never had a calculus class where every student got an A or a B. I mean, we had no C's, no D's, and no F's. And like I said, that was just pretty amazing to me. And so I want to have you give yourselves a hand for a great semester last semester. That actually is pretty amazing. I like I said, in 32 years of teaching, of course I haven't taught calculus all those years, but anyway, I was just kind of blown away when I looked at the overall grades and so on. And so that was pretty cool. So maybe our goal should be to do the same this semester, is just A's and B's, nothing less than that. So and I think you can do it. Some people ask me, is Calc 2 much harder than Calc 1? And I will tell you this, is that in some way, the reason why I think Calc 2 is harder for some people is that you have to remember all of Calc 1. You have to remember how to take a derivative and how to do the integrals. And we'll review that along the way. But as far as the new material, I don't know. I don't think overall it's harder. It's just that you do have to remember a lot of what we've done before. So that part maybe makes it tough, but we'll review. The other thing, let's go ahead and I guess let's talk for a minute about the the syllabus, just to mainly see if you have questions on it. So the preliminary information is pretty much the same. The idea is, and we'll talk about this more during the class, it's Calc 2 is to prepare you for either Calc 3 or differential equations. And so like I said, we'll talk more about that. We're using the same book. We'll cover 5 chapters. So if you sort of felt like I did, where, I never really feel super comfortable about chapter 6, because it always feels like that it just feels too rushed, the way that we teach it. But in this, we just have to deal with 5 chapters. And actually some of it we kind of skip around a little bit even. And so it's actually less than 5 full chapters. Now, chapters 7 and 8 are pretty big chapters. And so we'll get to like that. We'll take the midterm after chapter 7 and 8. And then 9, 10, and 11 actually go pretty quickly. So, and once again, this is a 4 credit hour class. Hey, Joey. Good to see you. Attendance breakdown of the grade is about the same. Letter grade. Quizzes and tests will be doing the same. One thing that I was kind of curious about is, so I had a number of people in their evaluations talk about wouldn't it be great if quizzes and tests, you didn't have to take the average, but instead you could take the highest score. I'm actually working on a possibility there. I don't know if it's going to be ready right away, but what I'm looking at doing maybe is, the trade-off there is, something that I've been working on is trying to make it so that there's a little more randomization for the tests and the quizzes. So what I mean by that is that, maybe your 5 questions on quiz 6.1 might be slightly different than somebody else's, or the order of the answers would be different. And so that way, I actually would give you, if I could pull that off and randomize it a little bit, then I actually might make the tests and the quizzes so that they take the highest of your 2 scores. The downside of that, at least from a student perspective, is one of the things I've told you to do when you are retaking a test or a quiz, to first mark the ones that you got right. Well, your answer that you got right on the first attempt might have been A on the first attempt, and that same answer might be B on their second attempt. So you'll have to spend a little more time with that. But I still think overall, if I can do what I think I can do here on these, then I'll actually change it so that it will give you the highest of the 2 scores instead of the average. So more to come on that. But several of you mentioned that, and so I've been kind of trying to work on that a little bit. Let's see, midterms and finals will go about the same. Remember, if prior arrangements haven't been made, you'll get a score of 0. No quizzes or tests opened after the midterm or final. Now, I did have a few issues. I can't remember in this class. Mostly it was in my afternoon Talon class, my afternoon college algebra. But I had several students that were sending me emails and I wasn't getting them. Can't remember if that happened in here. But what it was is that it was getting routed to my junk email. And so number one, I've learned I've got to check that more often. But number two is when you send me an email, it works best if you send it to me from your MPC email, and then if you put something in the subject line, like question on quiz or whatever. Okay, it's if you send something from Hotmail and you don't put a subject line, then whatever algorithm the school uses when it goes through the filters, if it doesn't see a subject line, it thinks of it as junk mail. And so that can really help us, I think, if you'll help clean that up a little bit. Okay, let's see. Also, we talked about timing, and like I said, there's actually going to be fewer quizzes this time, and I'm hoping that we can either do maybe just 2 quizzes a week instead of 3. I don't know if that will work, but that's my hope, is that we can limit it to 2. And then if we start needing extra, I want to kind of build in a few Moodle days that we have, maybe at least 1 per chapter, so that we just have a Moodle day where you get caught up on quizzes or the second attempt on the test or something. But just remember, this is the big idea on that, is that if you don't think you can finish an attempt in the time allotted, then just don't start it. Okay? For any reason, just don't start it, and then email me, and then we'll set another time. Okay? Talk to your talent aide, and we'll work that out. Let's see. Study tips are the same. Okay. Now there was someone in their evaluation that talked about tutor.com. Okay. Would just as a show of hands, would you guys tell me if you tried tutor.com? Just raise your hand if you tried it. Okay. So Joey, I think it was you that had kind of a negative experience there. Could you tell me a little bit more about that?
Well, I would try getting on every once in a while, and every time I would try getting on, it would just show a loading sign and say waiting for a tutor. And there were times when I would just leave that open for multiple hours and nothing would change.
Wow.
So I don't know if I was going to the wrong section on that website or what.
Okay. All right. How about you, Jordan?
So with a quick thing on Joey's, one of my computers was doing the same thing, and I would switch computers, and I was able to access tutor.com. So it might be your computer, Joey, just as a tip, because I was having that same problem. I liked it. There were times when the tutor would start doing something, and I'm like, I have no idea what you're doing. We haven't gotten over this. And then, if it was in a book, the answer they got would not be the answer in the book, and I was confused. But most of the time, it helped me work through the problem. Oh, this is what I'm missing. This is what I forgot. And it was helpful just to have an extra pair of eyes watching.
So going back to the computer issue, and thank you for that feedback, but I was just wondering if it was the browser that's different. Could it be the browser, or do you think it was the actual computer that made a difference, Jordan?
I think it was the actual computer. So my parents put on our computers some safety webs, so things don't come up. But it also prevents things like tutor.com, so I can't use it on those computers. So there might be something similar on Joey's where there's some complication that's not letting it go through.
Okay. All right. So try that, Joey, and then if there's still issues like that, technical issues, I want to know about that. Okay. So if that comes up again, shoot me an email. Okay. All right. Okay. So was there any other questions about anything on the syllabus? Okay. So like I said, pretty much it's going to be the same format. Okay, now Okay, so one other issue I do want to talk about, and this really, it wasn't, I'm not really directing these comments at anybody, because this was a good thing. But in general, I do want to say one thing that's, and especially now where there's only 2 or 3 of you in each classroom, that remember, as a college student, you have a lot of responsibility as far as, especially the way this course is taught, as far as your classroom environment. I was always really big on, when I was teaching the class live, if there were issues or distractions, or if there was a student that made it difficult for other students to learn, I wouldn't allow that to happen. And more than once I asked a student to leave. And so if there is an issue and someone is wanting to carry on conversation with you or with someone else and it's distracting, or like I had one student last year or last semester that in my evening class that would actually just watch videos during class. And it's one thing for you to check out and be distracted or not focused, but when you start affecting other people, then that's when I go crazy. So please, try to be respectful of your classmates. And it's like when like for example, there's sometimes when we come on and I'm taking roll and I see somebody on their phone, that's not a big deal to me. But when I'm actually teaching and you're checking texts, responding to texts, or watching a YouTube video or whatever, that's not acceptable. Okay, so just kind of keep that in mind. And really, that's probably going to be true for any of your college classes. But you would be amazed when you go to college, you sit in the back of a room and you'll be amazed at how many students just sort of mentally check out. And you can't do that. In a class like this, I need your whole brains. I need 100% of your attention, at least as much as possible. Okay? So, but let me know if there's an issue. And like I said, I anticipate 0 issues, but if something comes up, please let me know. I mean, the problem that I have, in all honesty, the distractions that I see that you guys have to deal with are ones that the school creates. Like that crazy bell at St. John's, or people coming in distracting in the library, or people talking to you while you're taking notes. I mean, that's tough. That's tough for you to deal with. But we'll just continue to do our best. So anyway, any questions, comments, concerns? Okay. All right. Well, so today we want to start in on 7.1. So any issues as far as did everyone get the guided notes, the student success organizers? Anybody not have that in their possession? One of the things that I'm going to try to do this semester is, as I send those out to your talent aids, I'm going to try to post them on the Moodle as well, so that if you happen to be gone that day or whatever, you can still kind of see what we're doing. Okay? All right. Oops. Okay, so this first chapter is on what's called transcendental functions. Okay. Now, does anyone know what a transcendental function is?
I know what transcendentalism is.
What's
It's
that?
like it was like a movement with like higher thought, I guess. So
Yeah.
something like that.
Yeah, like transcendental meditation or whatever. And so,
Yeah.
so I'm going to sit cross-legged on there and we're going to do some, no, we're not doing that. But yeah, it's, the idea is it's sort of like a higher plane. It's a higher mode of thought. Okay. See, when we start with, we start with like, polynomials. So that's a polynomial function. And we did derivatives and integrals of polynomial functions. Okay. Then we did trig functions. Okay. So then we did derivatives and integrals of trig functions. Okay. So now we're going to be doing a new kind of function that we've never dealt with, at least in this class, but you actually did in college algebra. And that's like, if you have like, like y equals natural log of x, or y equals e to the x. So exponential or logarithmic functions, those are examples of transcendental functions. So not polynomials, not trig functions anymore. And so we're going to learn how to take the derivative and how to do integrals of these. Now, actually, the calculus is pretty easy. The way that we do derivatives and integrals of those, that's not going to be the trouble here. Okay. Now, as we go through each section, so as we start in on section 1, okay, so within 24 hours, this is my goal, is that, I'm going to have the student success organizers to you ahead of time before we start each section. And then within 24 hours, I will post the lesson with extra examples. Now, typically, if you just need to see more examples of what we're doing, typically the lessons that I post have at least twice as many examples than what we've gone over in class. Okay? So if you just ever need to see more, then the lessons. And so what I'm going to do is I'm going to convert those to PDFs and then post them. Okay? And then, of course, we have the video. Now, I want to do those have a 24-hour turnaround, but in reality, the school has a 24-hour turnaround, and so sometimes that part's not going to work. And so what I'm going to try to do is say, well, if I can't do it within 24 hours, then on Thursdays, I'm going to try to, do the week if I haven't been able to do them every day. Okay. And then finally, we'll post, we'll have our quizzes. And then like I said, we're going to try to do, maybe limit it to 2 quizzes if we can, or, have a regular Moodle day. And so I'm looking at the schedule and seeing kind of where I can fit those in. Okay. But we do want to, so this Wednesday, so tomorrow, we're not going to worry about taking any quizzes or anything, but probably next Wednesday we'll start on that. Okay. All right. So this first section is on inverse functions and their derivatives. So the first part of this lesson is actually a review from college algebra, from Math 152. It's not, and so on the guided notes, just so you know, if you look, let's see here. So on the student success organizer, let me just because I would want to know this if I was a student. It's not till part 5 on the back page, that's when the calculus starts. Okay, so part 1 through 4 is going to be a review. Okay, so just kind of go along with me. So the first idea is what's called a one-to-one function. So a one-to-one function means this is like saying the y values here. So like y1 is not equal to y2 whenever the x values are not equal. So if you have if you have different y values when you have different x values, then that's called one-to-one. And sometimes you'll see it written 1-1. Now, you might remember the vertical line test. When you have a graph, you use the vertical line test to test if it's a function. And then in a minute, we'll talk about the horizontal line test, lets you know if the inverse is a function. If it has an inverse that's a function, let's say it that way. And so if a function has an inverse, then it's one-to-one. Okay? It's just another way to say it. Okay? So, is this a one-to-one function? Well, so you could sort of imagine like the square root function. That's the car hood. And so that would pass both a vertical and a horizontal line test. So that one would be one-to-one. Okay? Now, notice that, like, if I had, like, say, f of x equals x squared, like a parabola, see, that would fail the horizontal line test. So that would mean it does not have an inverse. So, like sine x, remember that the sine wave from trig, and so that would fail the horizontal line test. So typically, that would not be one-to-one. But what we do and we'll talk about this some more in just a minute, is when we want an inverse and we don't have one, this fails the horizontal line test, what we do is we'll just use part of the function. So like for sine, we'll just take off that part of it, and now that does have an inverse. And so for the inverse sine, we just restrict the domain to go from negative pi halves to pi halves. But just as it's written, this does not have an inverse. But when we restrict the domain, then we do have the inverse sign. And that's how we write it. Okay? So you have to, so it's a little tricky. It's a little tricky. Okay, so let's look at these. So it says determine if the following functions are one-to-one. Okay, so just answer these just how they're written. Not if you're, I mean, you could talk about restricting the domain or whatever, but just how they're written. Now, one of the things that you can do is, if you're not sure, then graph it. Do the graph and then do a vertical line test and a horizontal line test to see if it works. All right, so Hannah, what do you think about the cube root of x?
I think that is one-to-one.
It is one-to-one. You are correct. See, the graph looks like this. And so it actually passes the vertical line test, so it's a function, and then the horizontal line test, so it's 1-to-1. Good. All right. David, what do you think about the second one?
Did you say Nathan?
David.
Oh, I don't think it's 1-1.
Okay, it's not. It's not because the original graph goes on and on forever. So to make it have an inverse, like the sine wave, we can cut it and just look at part of it. And then that will have an inverse. So when we talk about the inverse sine and the inverse cosine, the only way those exist is if we restrict the domain. Okay? But as it's written, the answer to both of those would be no. No, I mean, that one's yes. Sorry. Yes and no. Okay. Okay. So a function y equals f of x is 1-to-1 if and only if its graph intersects each horizontal line at most once. So first you determine it's a function from the vertical line test, and then second you determine it's 1-to-1 from the horizontal line test. Okay. All right, so an inverse function. So suppose that f is a 1-to-1 function on a domain D with range R. The inverse function, and then that's f and a little -1, that's the function that sort of takes you back to where you start. So if like the f of 2 is 5, then the f inverse of 5 takes you back to 2. So the domain of f inverse is R, and the range of f inverse is D. So, couple of comments here. First of all, I hate the notation for inverse, because the little -1, we're sort of used to using that as an exponent, okay? But it's not the same. It's not the same. See, if I have x to the -1, you would use the elevator rule on that and say that's 1/x. But f to the -1, that means inverse. That's not an exponent. So if it's on a function, you don't use the elevator rule because it's not an exponent. Okay? And I hate that because that's confusing to a lot of students. But it is what it is. So the domains and the ranges of f and f inverse are interchanged. So the domain of f becomes the range of f inverse, and so on. So let's say this is my function here. Okay, I don't even have the function rule. This function is just as a table. So if I wanted the table for the inverse, then all you do is just interchange the x's and the y's. Okay? All right, so go ahead and do practice 2. All right, so just kind of check. Basically, you're just interchanging the x's and the y's. Okay. So I don't anticipate any problems. But did anyone have a question on those? Okay. Good deal. Okay, so now we'll talk about this more later. Since I've got the slide up here, one way that you can tell if you have the inverse function is if you graph the original function and you graph the inverse, then they will be symmetric through the line y equals x. Okay, so like if you imagine if that's your mirror or your paper fold or whatever, then one function, if it goes right on top of the other, then that graphically that shows that they're inverses. Okay, so we're going to use that idea in just a few minutes to determine if we have a function and its inverse. Okay, so to find the inverse of a function, number one, you solve for y and interchange x and y. And then step two, you solve for the new y, and then that's the inverse function. All right. So here f of x, if you have it in terms of f of x, just change that to a y. And then you're going to interchange the x and the y. And so now you think algebra, what do I got to do to get that y by itself? So here you'd subtract 1 and then multiply by 2. And so then when you solve for that new y, then that is the inverse function. Okay? So go ahead and try practice 3. All right, Skylar, when you've got
X minus 5 over 3.
it. Okay. So let's see. No, it'll be x plus 5. Because you add 5 to each side. Okay? Do you see that? Why it's got to be plus? Now,
Yeah.
And you can write it as, like you did, x plus 5 over 3. Or if you split it, that's okay too. So 1/3 x plus 5/3. Either way is perfectly fine. Okay? All right, any questions on that? All right, so it says for some functions to have an inverse, we must restrict the domain. So that's where I'm talking about in order to, like with the sine and cosine or whatever, or like with the parabola, see, if we want to make this satisfy the horizontal line test, if we just use half of it, the parabola, so we'll say, okay, let's only use the positive values for x. Okay. So for x squared, if we just restrict the domain, then it will have an inverse. Okay. So look at practice 4 and tell me what could we restrict the domain there in order to make it have an inverse.
Whenever x is greater than or equal to 0.
Yes, the same thing. And so that's a very common restriction. And so sometimes you can kind of see it from like the function, like we can't have negative values under there. So x has got to be positive or 0. Or sometimes you can see it from the graph and say, oh, we can't have that, but if we only had that half of it, we'd be okay. So then restrict it to just the positive values of x. And so you are absolutely right. So just make sure that if you restrict it to x is greater than or equal to 0, now that's going to have an inverse. Okay. So like inverse sine, we restrict that from like negative pi halves to pi halves, or cosine, we restrict that from 0 to pi so that we can get an inverse. Okay. All right. Well, you know what? So that's kind of the review of inverses. So part 5 is where we are, and that's with the calculus. So let's start there tomorrow. Plus, I have to let you out a little early the first day of class, right? That's kind of a rule. Okay. So anyway, so good to see you guys. And also tomorrow, I'm going to ask if anybody did anything amazing over the break. So be thinking about amazingness that you are. So we'll talk about that tomorrow. So anyway, you guys have a great rest of the day, and we'll see you tomorrow then.